Hello and welcome to the second video in this series where I go through a GCSE Maths Foundation Tier paper. Now I've already gone through paper 1, which was the non-calculator paper, so if you haven't already done so I recommend watching that video. I'll put a link up here in the top corner of this video. And for this particular paper I've put a link in the video description. So if you'd like to follow along at home, make sure you've obviously got your calculators ready and click on that link and go through the paper alongside me. So with all of that out of the way, let's get cracking. Question 1, write down the value of the 3 in the number 16.35. So we've got the number 16.35. So what do all of these digits mean? Well, this is our tens column. So this is 10. The 6 is our units column, so we've got 6 units. This here, this 3 is our tenths column, so it means 3 tenths, or we could say 0.3. And finally the 5, well, that is our hundredths column, so that represents 5 100ths, or we could say 0.05. So it's just asking us for the value of the 3, so the 3 corresponds to 3 tenths, or 0.3. Question 2, here is a list of numbers. Which number in the list is not a factor of 24? So let's go through all of the numbers. Is 1 a factor of 24? Well, yes, 1 is a factor of all numbers. Is 3 a factor of 24? Yes, because 3 times 8 is 24. What about 6? Well, 6 is also a factor of 24 because 6 times 4 is 24. 9, is 9 a factor? Well, no, 9 is not a factor. If we do the 9 times table, we've got 9, 18, 27. So 9 is definitely not a factor of 24. Let's just check the other ones. So 12 is a factor because 12 times 2 is 24. And 24 is a factor because 24 times 1 is 24. So 9 is the only number that is not a factor. So that is our answer, 9. Question 3, write 0.21 as a fraction. So at the moment we've got a decimal, 0.21, and we want to turn it into a fraction. Well, at the moment, 0.21, we could write that as just 0.21 over 1, but this isn't a valid fraction because we've got a decimal. You can't have a decimal within a fraction, so how would we get rid of this decimal point? Well, we could multiply by 100. If we multiply by 100, that will get rid of the decimal because that 0.21 times 100 is 21. But whatever we do to the top of a fraction, we have to do the same to the bottom. So we have to multiply that by 100 as well. 1 times 100 is 100. So this is our answer, 21 over 100. Question 4, simplify 5f minus f plus 2f. So when we simplify expressions, we can just collect like terms. So imagine these F's were footballs. If we've got 5 footballs, we take away 1 football, we're left with 4 footballs. And then we add 2 footballs, we're now left with 6 footballs. So our answer is 6F. Part B, simplify 2 times m times n times 8. Now with multiplication, the order does not matter. So we could group the numbers together. So 2 times 8 and then times m times n. These are exactly the same thing. So let's just evaluate what 2 times 8 is. Well, 2 times 8 is 16, and then multiplied by m times n. When we multiply variables together, we could just put the letters next to each other. So that is just the same as mn. But also, when we multiply any number with any combination of variables, again, we can just put them together. So this is exactly the same as 16mn. So that is our answer, 16mn. And finally, part C, simplify t squared plus t squared. Well, this is very similar to this question up here. We're just adding together like terms. So in front of this t squared, that's just a 1. We just don't write it. So we've got 1 t squared plus another t squared. Well, how many t squareds does that give us? Well, it gives us 2 t squareds. So that is our answer. Question 5. A shop sells pens at different prices. The cheapest pens in the shop cost 27 pence each. Lottie buys 18 pens from the shop and she pays with a £10 note. If Lottie buys 18 of the cheapest pens, how much change should Lottie get? So first of all, let's just work out how much money Lottie spends. So each pen costs 27 pence and she buys 18 of them. So we can just do 27 pence multiplied by 18. And remember, a lot of people forget you are allowed to use your calculator. So 27 times 18. Don't try and do long multiplication because you will just be wasting time. So just pop this into a calculator and that gives me 486 pence. But it's probably easier to work in pounds and pence. So that is exactly the same as £4.86. So that's the amount of money she spends. So how much change does she get? Well, we just need to take this away from £10. So we're going to do £10, take away £4.86 minus 4.86, and we get £5.14. So that is our answer, £5.14. Okay, part B. Instead of buying the cheapest pens, Lottie buys 18 of the more expensive pens. She still pays with a £10 note. How does this affect the amount of change she should get? Well, if she's buying more expensive pens, that means it's going to cost more money. So because it's costing more money, she's going to get less change. So we can say that as she is spending more money, she will get less change. And this is only worth 1 mark, this last one. Question 6. Michelle and Wayne have saved a total of £458 for their holiday. Wayne saved £72 more than Michelle. How much did Wayne save? Now the first thing I'm going to do is just write a key for Michelle and Wayne. So instead of writing Michelle all the time, well, I'm just going to use the letter M. And instead of using Wayne all the time, well, I'm just going to use the letter W just to make things a bit easier. So we know together they saved £458. So I can say that M plus W is equal to 458. But in this second line, I'm also told how much Wayne saved. So it says that Wayne saved £72 more than Michelle. So Wayne must equal Michelle's savings plus 72. So now I've got 2 equations here. So notice I've got an expression for how much Wayne saved. So he saved M plus 72. So wherever we see a W, I can just replace this W with M plus 72. So I'm just going to rewrite this first equation. So we've got M plus W. Well, we know that W is M plus 72. And we know that equals 458. And now we can just solve this equation. So if we simplify, we get 2M plus 72 is equal to 458. Now if we subtract 72 from both sides, we get 2M is equal to, let's just get the calculator out, 458 minus 72, which is 386. And now if I divide both sides by 2, I get M is equal to 193. So I know how much money Michelle saved now. So Wayne, we know that Wayne saved £72 more than Michelle. So we just need to add on £72. So it'll be £193 plus £72. So let's just work that out on the calculator. Plus 72, £265. So that is the amount of money Wayne saved, which is what we want. So that's our answer, £265. Question 7. Work out 70% of £90. So we've got £90 and we're just going to multiply it by 70%. Or if we convert this to a decimal, that is just 0.7. So we're just going to do £90 multiplied by 0.7. We can use a calculator, but I know that 9 times 7 is 63. So this is the same as £63. So that is our answer, £63. Question 8. Here are 4 fractions. Write these fractions in order of size. Start with the smallest fraction first. Now, whenever you're asked to convert fractions, there's a couple of ways you could do it. You could turn these fractions into equivalent fractions that have the same denominator. Or, because this is a calculator paper, the easiest thing to do is just type this into a calculator and put them all as decimals. So a half, well, I know that's the same as 0.5. If I do 17 out of 24, I just need to type that into a calculator. 17 over 24, and I get 0.71. 0.71. I've just rounded that to 2 decimal places. 3 over 4, well, that is the same as 0.75. And 5 out of 12, again, let's type that into a calculator. 5 over 12, that is 0.42. 0.42. And now I've got them as decimals, it's much easier to compare. So I'm starting with the smallest, well, that is this one here. But remember, I need to write in the fraction. So 5 over 12 is the smallest. Then the next smallest is this one, 1 over 2. And then we go up to 17 over 24. And then the biggest one is 3/4. Okay, so much easier with a calculator. If this was on a non-calculator paper, which it is likely that it would be, this sort of question, then you would just convert them into equivalent fractions. Question 9. What percentage of this shape is shaded? So first of all, let's just count how many boxes we've got. So we've got 1, 2, 3, 4, 5 across and 1, 2, 3, 4 down. So we've got 20 boxes. And how many of those are shaded? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 whole shaded. But then this one and this one will give us 11. This one and this one will give us 12. And then we've got a half left over. So we've got 12 and a half. So we've got 12 and a half boxes that are shaded. So to work out the percentage that are shaded, well, we're just going to do 12.5 over 20. That will give it, that is as a fraction. So as a fraction, 12.5 out of 20 are shaded. And then to convert that into a percentage, we just need to multiply it by 100. So let's get the calculator out. 12.5 divided by 20 times by 100. And we get 62.5. So 62.5%. And the percentage symbol is already given to us, so we just need to write in 62.5. Question 10. The manager of a clothes shop recorded the size of each dress sold in one morning. So here's the different sizes. The sizes of dresses are always even numbers, which we can see here. The mean size of the dresses sold that morning is 15.3. And the manager says the mean size of the dresses is not a very useful average. Explain why the manager is right. So why is the mean, which is 15.3, not very useful in this situation? Well, simply because you cannot have a dress size that is 15.3. We know the dress sizes only come in even numbers, so having this value of 15.3 doesn't give us any information. So you cannot have a dress size of 15.3. Now part 2, which is the more useful average for the manager to know, the median or the mode? You must give a reason for your answer. So let's just recap what these two things mean. So the median is just the number that's in the middle, so they're already in order. We would just select the middle one. And the mode is just the most common or the most popular. So which dress size appears the most? And we can see that 14 appears the most, so that would be the mode. So out of those two, which one would be the more useful for the manager to know about? Well, it would be the mode. The mode is the most useful because it tells us what dress size is the most popular. So let's write that down. It tells the manager which dress size is the most popular, which is obviously really important for him. He wants to know this sort of information so that then he can he can order more size 14 dresses. if they're the most popular. So definitely the mode. Question 11. In a shop, the normal price of a coat is £65. The shop has a sale. In week 1 of the sale, the price of the coat is reduced by 20%. And then in week 2 of the sale, the price of the coat is reduced by a further £10. Now, Maria has £80. Does Maria have enough money to buy the coat in week 2 of the sale? You must show how you get your answer. So let's work out how much money the coat costs in week 2. So it starts off at £65. Now, the price of the coat is reduced by 20%. Now, if it's being reduced by 20%, it obviously started at 100% because that's just the normal price. So if it's being reduced by 20%, it is now worth 80% of the original price. So to work out how much it costs, we can just multiply the original price by 80% or 0.8. 80% is the same as 0.8. So I'm just going to write here reduced by 20% just to show you what this 0.8 actually means. So 65 times 0.8, let's put that into the calculator, and we get £52. So £52, so she can't afford it yet, but now in week 2 of the sale, the price of the coat is reduced by a further £10. So I'm just going to put week 1 here. Week 2, well, we need to take £10 away. So it's going to be £52, take away £10, which is obviously, you don't need a calculator for that. That is £42. So that is the price of the coat in week 2. Maria has £40. So let's answer the question. Does she have enough money? So clearly no. She is £2 short. So she's only got £40, so she is £2 short. Question 12. The length of a car is 3.6 meters. Carl makes a scale model of the car, and he uses a scale of 1 centimeter to 30 centimeters. Work out the length of the scale model of the car. Give your answer in centimeters. So we know what the real life length of the car is. We need to work out what it is on the scale. So, and we need it in centimeters. So length of the car. Let's write the length of the car in centimeters. So if it's 3.6 meters, to go from meters to centimeters, we need to multiply by 100. So 3.6 times 100, well, that's going to be 360. So the length of the car is 360 centimeters. So let's think about the scale now. So the scale to real life. So for every 1 centimeter on the scale, that corresponds to 30 centimeters in real life. Now we know what the real life length of the car is. That is 360 centimeters. So we just need to work out the scale. So there's a couple of ways we could do this. The way I'm thinking is that to go from the real life to the scale, we divide by 30. It's 30 times smaller. So if we just divide this by 30, that will give us the scale. So 360 divided by 30, or that would be 12 centimeters. And it asks us for the answer in centimeters, so we're all good there. So our answer is 12. Question 13. Here are the heights in centimeters of 15 children, which we can see here. Part A, show this information in a stem and leaf diagram. Now, whenever I have to do a stem and leaf diagram, I always do my own one first, which won't be in order, and then I can put it in order on the finished one. Because it's going to be a lot easier that way. Otherwise, you'll have lots of crossings out and things like that. So if I go through all of the numbers, I can see that we're starting in the 120s. So I'm going to put 1 and 2 here for 120. And then we're going all the way up to, I think the maximum is 151. So we're going to have 120, 130, 140, and 150s. And now I can just go through the list. So 123, 147, 135, 150, 147, 129, 148, 149, 125, 137, 133, 138, 133, 130, and 151. Let's just make sure we've got 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But the reason I've done it like this is now I can just transfer them onto this one. So I've got 120, 130, 140, 150. But now I can see the order. So 123 is the smallest, then 125, then 129. Now if we do the 130s, we've got 130, and then 133, and we've got another 133, and then 135, 137, and 138. And then the 140s, well, that's already in order, so I can just copy that down. 7, 7, 8, 9, and this is already in order as well, so 0, 1. Now, all of this here will give me 2 marks, but notice it is worth 3 marks. With all stem and leaf diagrams, you need a key. Okay, you need a key. So what does this mean? Because we don't know anything about what this means. We've just got random numbers here. So we pick one at random. So this here. So this would be 123. Well, that equals 123 centimeters. So we need to say, include this information to tell people what this diagram means. Okay, so that would give you your 3rd mark. Okay, moving on to part B. One of the children is chosen at random. What is the probability that this child has a height greater than 140 centimeters? So how many students or how many children have a height greater than 140 centimeters? Well, 1, 2, 3, 4, 5, 6. So there are 6 children in total. Out of the total number, well, there are 15 children in total. So that is our answer, 6 out of 15. So we don't need to simplify that. I'm just going to leave that as my answer, 6 over 15. Now, just going back to 13a, I just want to make it clear that you do need your numbers in order. Okay, so if you don't put them in order, you will lose a mark. So that's why I did my draft stem and leaf first, because after I did this, it makes it much easier to see the order of the numbers so that then I could put them in the grid below. Question 14. Write down the coordinates of point C. So this is point C here. So what are the coordinates of that point? Well, remember, whenever we are dealing with coordinates, we always go along the corridor and up the stairs. That's how I like to remember it. So we are not going along the corridor at all. So our x coordinate is 0, and we're going down the stairs 1 unit. So it will be 0, -1. Okay, part B. It says ABCD is a square. On the grid, mark with a cross the point D so that ABCD is a square. At the moment, we've got A, B, and C. So D, to make D a square, it's going to be somewhere over here. So let's just think about exactly where it's going to go. So remember, a square is a type of parallelogram. So the opposite sides have to be parallel. So if we were to draw in, let's just draw in a line as part of our square. I mean, that's a bit thick, so let's just make it a bit thinner. So that is one side of our square. Let's do one of the other sides. So from B to C, like this. Now this length here, from C to D, that needs to be parallel with this length here, B to A. So if let's look at what the gradient of this line is. We're going along 1, 2, 3, and then up 1. So here we're also going to have to do the same. So we're going to go along 1, 2, 3, and up 1. So it's going to be, let's just put a little point here. So that is where D is going to be. So it says on the grid, mark with a cross the point D. So let's do that. So D is going to be this point here. And just to prove that is the right point, let's just connect all of the points together just to show you that it will make a square. So there we go. And you can see there is a square. So we obviously don't need those last 2 lines. And now moving on to part C, it says write down the coordinates of the midpoint of the line segment BC. So first of all, what is line segment BC? Well, that's this line segment here. So we need to find the midpoint of this line here. And just doing it by eye, I think it's going to be around here somewhere. But let's get an exact value. So to calculate the midpoint, we just need to take the average of the x and the y coordinates. So let's write down what the coordinates b and c are. So b, well, that is -1, 2, -1, 2. And c, well, we already know what c is. That is 0, -1. So the midpoint is just going to be the average of the x coordinates and then the average of the y coordinates, or the mean average, I should say. So to calculate the mean, we just add the two numbers together and divide by 2. So the x coordinate is going to be -1 plus 0 divided by 2. Well, that's just going to be -1/2. So that is our x coordinate, -1/2. And our y coordinate, we're going to take the mean of the y coordinates. So it's going to be 2 plus -1 over 2. Well, 2 plus -1, that's the same as 2 minus 1, which is 1. So that would be 1 over 2. So that is our y coordinate, 1 over 2. And let's just dummy check that. That does look like it makes sense. That is about those. So the x coordinate, we're going along -1/2 and we're going up 1/2. So that is our answer. Question 15a, work out 4/5 of 210 centimetres. So 4/5 of 210, well, we just take 210 and we multiply it by 4/5. So let's just get our calculator out just to save time. I could do this without a calculator, but as this is a calculator test, it makes more sense. And we get 168. So that is 168 centimetres. Okay, part B, work out all of this business. So this is definitely testing your calculator skills. So you'll need to type this into a calculator. So the first thing to do is to open the brackets. Type in 6 minus 2.5. So let me do that. 6 minus 2.5. And then we close the brackets. And then do the squared symbol. Plus. And then we open the square root. So square root symbol. And then in the square root space, we just type in this difference here. So 9.34 minus 2.58. So 9.34 minus 2.58. And we should get, so when you type it into the calculator, it should come up saying 297 over 20. And then you can press the SD button to give it to you as a decimal. That is 14.85. It doesn't matter which one of these you use, so I'm just going to use the first one because it doesn't say give your answer as a fraction or a decimal, so either of these would be correct. Question 16a, solve this equation. So let me just write it out here. So we've got 4c plus 5 equals 11. So the first thing I'm going to do is get rid of this 5. So if I subtract 5 from both sides, I'm left with 4c is equal to 6. Now if I divide both sides by 4, I get c is equal to 6 over 4, which we can simplify. I can divide both numbers by 2, so that is 3 over 2. So that is our answer, 3 over 2. Part B, solve this equation here. There's two ways we could do this. I could multiply out the brackets. So let me just write it out in full. So we've got 5 in brackets e plus 7 equals 20. So I could multiply out the brackets, but what I'm going to do is I'm just going to get rid of this 5. So I can see that this expression is being multiplied by 5. So to get rid of this, I can just divide both sides by 5. So if I divide both sides by 5, I get e plus 7 is equal to 4. And now I can subtract 7 from both sides. I get e is equal to -3. So that's my answer. And just to show you that it works both ways, I'll expand the brackets. So I'll do it the other way. So if I expand these brackets, I get 5e plus 35 is equal to 20. And now if I subtract 35 from both sides, I get 5e is equal to -15. and then divide both sides by 5, I get e is equal to -3. So it doesn't matter which way we do it. Okay, part C, simplify this here. Now it's quite hard to see on the screen, but what we've got is we've got m cubed, and then all of that is being raised to the power 2, or being squared. Now, whenever we raise something to a power and then a further power, we multiply these indices. So that becomes m to the power of 3 times 2, which is 6. So that is our answer, m to the power 6. Question 17. ABC is a right angle triangle, which we can see here. P is a point on AB, and Q is a point on AC, and AP equals AQ, which we can see by these dashed lines. Work out the size of angle AQP. You must give a reason for each stage of your working. Now this is worth 4 marks, and a lot of people drop marks not for giving correct reasons with these types of questions. So what angle are we trying to find out? AQP. So AQP, it's this angle here that we're trying to work out. So we are given one angle. We also know this angle here. So I can work out this angle. So I can work out angle QAP. So angle QAP. Well, that is going to be, we know that angles in a triangle add up to 180. So it's going to be 180 minus 22 minus 90. So let's just put that into the calculator. 180 minus 22 minus 90. We get 68 degrees. So angle QAP is 68 degrees, but we must give a reason for our answer as well. So I'm just going to put in brackets, angles in a triangle. Actually, I'm going to write out triangle just because I don't want to leave any confusion. Angles in a triangle sum to 180 degrees. So we've done the first part. So let's just write in here, that is 68 degrees. Now, we're also told that this is an isosceles triangle. So these two angles here are the same. So because they're the same, we can let's just call them x. So we can say that x plus 68 is equal to 180 degrees. And then we can just simplify this and then solve. So that gives us 2x plus 68 is equal to 180. And now if we subtract 68 from both sides, we get 2x is equal to 112, I believe. Yep, 112. And now we can just divide both sides by 2. We get x is equal to, that is going to be 56 degrees, I believe. Yeah, 56 degrees. Now, we do need to give another reason. So what piece of mathematical information did I use? Well, that was that base angles of an isosceles triangle are equal. So I'm just going to write that down. So base angles of an isosceles triangle are equal. So notice how I've found out 2 pieces of information, but for both pieces I've given reasons. So let's just finish off by saying angle AQP is equal to 56 degrees. Well, it's equal to x, which is equal to 56 degrees, and that is our final answer. Question 18. Here is a list of ingredients for making 16 mince pies. Elaine wants to make 72 mince pies. How much of each ingredient will Elaine need? So we've got ingredients for 16 mince pies. Now we need to make 72. So what we can do is, if we find a factor of 16 and 72, and the highest common factor of both numbers is 8. Let me write that down. So the highest common factor of 16 and 72 is 8. What we can do is we can work out the ingredients for 8 mince pies and then just multiply it by 9 to get 72. So let's write this down here. So for 8, I'm just going to put MP for 8 mince pies. So for 8 mince pies, how much butter do we need? Well, we're just halving everything, because to go from 16 to 8, we just divide by 2. So we're going to half everything. So we've got 120 grams of butter. Half of 350 is 175. 175 grams of flour. Half of 100 is 50. So 50 grams of sugar. And then half of 280 is 140. So 140 grams of mincemeat. Okay, so now we know how much ingredients for 8 mince pies. We can now do 72 mince pies. So 72 mince pies. We just need to multiply everything by 9. So 120 times 9. Let's just get the calculator out. 120 times 9. 1080. 1080 grams of butter. 175 times 9 is 1575. 1575 grams of flour. 50 times 9, I can do that in my head. That's 450. And 140 times 9, that is 1260. 1260 grams of mincemeat. So let's just write in these answers. So we've got 1080, 1575, 450, and 1260. So there are a few ways of doing this, but I think this is definitely the easiest way to find the highest common factor of both numbers. So then you can just divide this by some number and then multiply it by some number to get how many you need. Question 19. Lethna worked out 2/5 plus a half, and she wrote down this calculation here. The answer of 3/10 is wrong. Describe one mistake that Lethna made. Now, whenever you're asked to spot mistakes, just do the calculation yourself and then compare your answer with theirs to see where they went wrong. So let's work out what this is. So we've got 2/5 plus a half. So we can only add or subtract fractions where the denominators are the same. So we're going to have to get a common denominator. And I can see the lowest common multiple of 5 and 2 is 10. So that's our denominator. So the first fraction, to go from 5 to 10, we need to multiply by 2. So 2 times 2 is 4. And then the second fraction, to go from 2 to 10, we multiply by 5. 1 times 5 is 5. So now we can add our fractions together. We get 9/10. So I can see that their denominators are correct. They have found the lowest common multiple, but they have forgot to multiply their numerators. I can see that they've still got the 2 and the 1 over here. So that's all they forgot to do. They forgot to multiply their numerators. So I can say Lethna forgot to multiply her numerators. Okay, moving on to part B. Dave worked out 1.5 multiplied by 5 1/3, and he wrote all of this business down. The answer of 5 1/6 is wrong. Describe one mistake that Dave made. So we only need one mistake. Now, just like over here, don't try and spot the mistake in their calculations. Just do it yourself. Do the calculation yourself. Work out what this is and see where they went wrong. So when we multiply mixed numbers, the easiest thing to do is to convert these into improper fractions. So 1.5, well, that's the same as 3/2. Multiplied by 5 1/3, well, that's 5 times 3 is 15, plus 1 is 16, so that's 16/3. And now we just need to multiply these two fractions together. And we can simplify this. So 3 divided by 3, these two will just cancel out with each other. So they will just become 1s. And 16 divided by 2 is 8. So that will become an 8 and that will become a 1. So 1 times 8 is 8. 1 times 1 is 1. So our answer is just 8. So one mistake that Dave made, well, Dave went completely wrong. He forgot to convert his mixed numbers to improper fractions. So Dave forgot to convert his mixed numbers to proper fractions. And we're done. Question 20. Make t the subject of the formula. So whenever you're asked to make something the subject, it always has to be t equals, okay? You want to get it on its own on one side of the equation. So our final answer, let's write it down here actually, our final answer should be t equals. So we want to get t on its own. Let's write it out down here. So w equals 3t plus 11. So we want to get t on its own. At the moment we're adding 11, so let's get rid of this. If we subtract 11 from both sides, we're left with w minus 11 is equal to 3t. And now we just want to get rid of this 3. At the moment we're multiplying by 3, so to get rid of it we do the opposite. So we divide by 3. So we divide both sides by 3, we get w minus 11 over 3 is equal to t. So it doesn't matter which way round we've put it. I've put the t on the left, so we can say that t is equal to w minus 11, all of that over 3. Question 21. 3 companies sell the same type of furniture. The price of the furniture from Pools of London is £1,480. The price of the furniture from Jardins of Paris is €1,980. And the price of furniture from Outways of New York is $2,250. So we've got all different currencies here, but we are given the exchange rates down here. Which company sells this furniture at the lowest price? You must show how you get your answer. So we've got 3 different currencies. We're going to have to convert all of them into the same currency. So I think what we'll do is let's convert all of them into pounds. Okay, just because we've got pounds here and we've got pounds here. So we already know how much it costs from Pools, okay, which is £1,480. Let's convert the price from Jardins. So Jardins is €1,980. So to go from euros to pounds, we need to divide by 1.34. Notice how to go from 1.34 to 1, we just divide by 1.34. So we need to divide this by 1.34. And I will definitely need my calculator for this. 1980 divided by 1.34. And that gives us, I'm just going to round it to the nearest penny. So that gives us £1,477.61. And now let's look at Outways. So Outways. So that is in dollars. That is $2,250. So if we look at our conversion, this time we're going to divide by 1.52. So if we divide by 1.52, let's type that in, 2250 divided by 1.52, and we get £1,480.26. So it's very close. I've just noticed it's very close between Pools and Outways, but it looks like actually the lowest price, this is the lowest price. I've just noticed this one here is about £3 lower than all of the others. So which company sells the furniture at the lowest price? We need to say that Jardins is the cheapest. Not the cheapest. And we've given all of the values, so we don't need to say anything more. That is fine. Jardins is the cheapest. Question 22. The time series graph gives some information about the number of pairs of shoes sold in a shoe shop in the first 6 months of 2014. So we've got the number of pairs of shoes sold on the y-axis and the month along the x-axis. The sales target for the first 6 months of 2014 was to sell a mean of 96 pairs of shoes per month. Did the shoe shop meet this sales target? You must show how you get your answer. So they need to have sold a mean of 96 pairs of shoes per month. Now, this was over a 6-month period, so we could work out the total number of shoes that they had to sell. So total shoes that needed to be sold. So how many shoes did they need to have sold? How many shoes did they need to have sold in order to meet their target? Well, it's going to be 96 times 6, because they had to sell 96 each month for 6 months. So let's work that out. 96 times 6, 576 that is. So they need to have sold 576 pairs of shoes. So how many did they sell? Well, we can add up all of these values. So let's first of all look at our axis. So this is 100 and 120. So we're going up by 20 pairs, and there are 10 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each square is 2 pairs. Each square is 2 pairs. So this is 100, 102, 104, 106, 108, 110. So we've got 110. This one here is going to be 82, 84. This one down here is 80. Take away 2, that's 78. This one here is going to be, well, I can see that's 90, 92, 94. This one here is bang on 90. And finally, this one here, that's bang on 120. So let's add up all of these. So 110 plus 84 plus 78 plus 94 plus 90 plus 120. And we get exactly 576, which is a bit of a coincidence. So we know they sold 576 shoes in total. So the mean would be 576 over the 6 months. Well, we know that that is 96. So did the shoe shop meet the sales target of 96 pairs of shoes? Yes, they did. Question 23. The grouped frequency table gives information about the heights of 30 students. Write down the modal class interval. Now, the modal class interval is just the interval that contains the mode. And the mode is the which one appears the most frequently. And we can see on this graph that the height that appears the most frequently is this one here, because it has a mode of 10. So this would be the modal class interval. So let's write that down. So it is 160, which is less than h, which is less than or equal to 170. Be really careful. A lot of people will write 10 as the mode. 10 is not the mode. 10 tells us where the mode is. So just be really careful there. Okay, part B. This incorrect frequency polygon has been drawn for the information in the table. Write down 2 things wrong with this incorrect frequency polygon. Now, I can see straight away one thing that's wrong with it, and that is this line here. You shouldn't connect the start to the end of the line. So that's the first thing that's wrong with it. So they connected the first and last points. That is definitely a no-no. Now, the second thing that's wrong with it, let's have a look at the axes. So we've got 0, 2, 4, 6, 8, 10, 12. That seems to be fine. We've got 120, 130, 140, 150, 160, 170, 180, 190. That seems fine. It's all going up in even intervals. Now, I'm just taking a look at the intervals here. So from 130 to 140, we've got a frequency of 1. Now, whenever we're plotting a frequency polygon, the points should be the midpoint of our category. Okay, so the midpoint of this category is 135, so it should be here. So this point here that's here should be 5 units along. It should be at the midpoint. And it looks like that's the case for all of the points, actually. So this point should be over here. This point should be over here. This point should be over here. And this point should be over here. So we can just say that they haven't used the midpoint for their height intervals. Okay, so whenever you're plotting a frequency polygon, always use the midpoint. The only times you use the end point, here they've used the beginning point, but you would use the end point if you're doing a cumulative frequency diagram. Okay, so cumulative frequency, we use the end point. Frequency polygons, we use the midpoint. Question 24. At 9 a.m, Bradley began a journey on his bicycle. From 9 a.m. to 9:36 a.m, he cycled at an average speed of 15 kilometers per hour. And then from 9:36 a.m. to 10:45 a.m, he cycled a further 8 kilometers. Draw a travel graph to show Bradley's journey. So we're starting at 9 a.m. We're starting down here, and obviously he hasn't travelled anywhere, so we'll start in the bottom left-hand corner of our grid. Now we're going to 9:36 a.m. So let's look at our diagram. Now this is 9:30 and this is 10. So this 30 minutes. Now I can see we've got 10 squares representing 30 minutes. So let's write this up here. So 10 squares equals 30 minutes. So therefore one square must be equal to 3 minutes, not 3 minutes. So where is 9:36? So that would be 9:33. That would be 9:36 here. So we just need to work out how far he travelled. So to work out distance, well, if we think about what the relationship is between speed, distance and time. So this is our relationship here. Speed is distance over time. So to work out the distance, we do the speed times the time. So the distance is the speed, which we know is 15 kilometers per hour, multiplied by the time. Well, the time is 36 minutes, so we can't write 36 here because we've got one of our units in hours and one in minutes. We need to write both of them in hours. So how many hours is 36 minutes? Well, to convert between minutes and hours, we divide by 60. So it's going to be 36 over 60 hours. So let's just type this into a calculator. So it's going to be 15 multiplied by 36 over 60. And that's nice because we get 9 kilometers. So he's travelled 9 kilometers. So we've got 5 kilometers here and 10 kilometers here. So there are 10 squares. So it looks like each square would be half a kilometre, or 2 squares would be 1 kilometre. So if that's 10, let's make sure we go up. So it's on this line here. If that's 10, 9 is going to be 2 squares below. So 9 is going to be there. So let's draw in our first part of the journey. So we're going from here up to here. And now let's read the next part. So from 9:36 a.m. to 10:45 a.m. he cycled a further 8 kilometers. So let's get my pen tool out. So up to 10:45 a.m. So 10:45 a.m. is here. It's halfway between 10:30 and 11. And a further 8 kilometers, if we're at 9 now and we're going a further 8, that will take us up to 17 kilometers. So we've now got up to 17. So that's 15, 16, 17. Is that right? No, done that last one wrong. Just because the line's a bit thicker. So 15, 16, that would be 17 there. So that's our second part of the journey. Up to that point there. And I think we're done with that now. Draw a travel graph to show Bradley's journey. Yep, this is our graph here. Right, moving on to part B. From 10:45 a.m. to 11 a.m, Bradley cycled at an average speed of 18 kilometers per hour. Work out the distance Bradley cycled from 10:45 a.m. to 11 a.m. So we know the speed and we know the time. We just need to work out the distance. So again, we're going to do speed times time. So the distance is going to be the speed, which is 18 kilometers per hour, multiplied by the time, and the time is 15 minutes or a quarter of an hour. So, and because we want it in hours, so it's going to be a quarter of an hour. So 18 times a quarter, well, that's just the same as 18 over 4 or 9 over 2 hours. Oh, sorry, not hours. I'm using, it's distance, isn't it? So that's kilometers, which is the same as 4.5. So 4.5 kilometers. So that is our answer, 4.5. And remember to include units, kilometers. Question 25. Toby invested £7,500 for 2 years in a savings account, and he was paid 4% per annum compound interest. How much money did Toby have in his savings account at the end of 2 years? So he started off with £7,500. Now, he gets 4% compound interest. So 4%, if he's getting 4% interest, the multiplier will be 1.04. But he's doing that for 2 years. So it'll be times 1.04 times 1.04, or just times 1.04 squared. So we just need to type this into a calculator. So 7,500 times 1.04 squared, and that gives us £8,112. And that is our answer, because it says how much money did he have in his savings account. Well, this is the amount of money he's now got. So it's £8,112. Question 26. Becky has some marbles. Chris has 2 times as many marbles as Becky, and Dan has 7 more marbles than Chris. They have a total of 57 marbles. Dan says, if I give some marbles to Becky, each of us will have the same number of marbles. Is Dan correct? You must show how you get your answer. There's quite a lot of text involved in this. So again, just like we did before, let's put labels for each person. So I'm going to say that Becky's marbles is B. Chris's marbles is going to be C. And Dan's marbles is going to be D. So Chris has 2 times as many marbles as Becky. So however many Chris has, he has 2 times the amount that Becky's got. So we can write C equals 2B. That's that one done. Now this one here, it says Dan has 7 more marbles than Chris. So Dan, I should really use lowercase. So Dan has 7 more marbles than Chris. So it'd be Chris plus 7. And then this one here, it says they have a total of 57 marbles. So B plus C plus D is equal to 57. So with all of this information, we've got 3 equations and we've got 3 unknowns. So with this, we can actually work out how many marbles each person has got. So first of all, we know that Dan has, or D equals C plus 7. So I can substitute that into this equation. So wherever I see a D, I can just replace that with C plus 7. So this is going to be B plus C plus plus 7, which is equal to 57. And then I can simplify this slightly because I've got C plus C. Well, this is going to be B plus 2C. And then if I subtract 7 from both sides, that equals 50. So I'm just simplifying it a bit. And now notice I've got an expression for C. So I know that C is 2 lots of B. Now I can pop this into this equation. So wherever I see a B, wherever I see a C, I should say, I can replace that with 2B. So we've got B plus 2 times C. Well, that is 2B. Like that. So I've just replaced C with 2B. And that equals 50. So now this is B plus 2 times 2B is 4B equals 50. So now we can simplify this. B plus 4B is 5B. So now we have 5B is equal to 50. And now we can divide both sides by 5. We get B is equal to 10. So I've figured out how many marbles Becky has. Now I can work out how many marbles everyone else has. So Chris has 2 lots of Becky. So Chris is 20. And Dan has Chris plus 7, so it'll be 20 plus 7, which is 27. And let's just make sure we've got 57 in total. No, we don't. I've made a mistake. Oh, I've just written 50 instead of 10. Sorry, I did work out it was 10. I just wrote down 50 for some reason. But Becky definitely has 10 marbles. And yes, they do indeed add up to 57. So we know we've got all of the allocation correct for each person. Let's have a look at what Dan says. If I give some marbles to Becky, each of us will have the same number of marbles. So if Dan gives some marbles to Becky, he's saying that they'll all have the same number. So Chris isn't getting involved in this. So Chris is staying at 20. So in order for Dan to have 20, he needs to give away 7. But in doing so, Becky will only be left with 17. So we can say, no, Dan is wrong. Dan is wrong. There is no way they can have 20 marbles each. They are 3 short because they've only got 57 marbles. So they are 3 marbles short. Question 27. Here is a diagram showing a rectangle, ABCD, and a circle. BC is a diameter of the circle. Calculate the percentage of the area of the rectangle that is shaded. Give your answer correct to 1 decimal place. So we need to work out the area of the rectangle that is shaded as a percentage of the whole area of the rectangle. So let's first of all work out what the area of the rectangle is. So area of rectangle, well, that's just base times width. So that's going to be 19 times 16. So 19 times 16, 304. So that's 304, and that is in centimeters squared. And now we need to work out the shaded region. So the shaded region is just going to be the rectangle minus the semicircle. So if we work out what the semicircle is, so area of semicircle, well, it's going to be the area of the whole circle divided by 2. So it's going to be pi r squared. That's how we work out the area of the whole circle divided by 2. So what is the radius of our circle? Well, we know this is the diameter. We're told that BC is the diameter, and this length is the same as this length. So this is 16. So the radius, let's just write the radius is equal to 8 centimeters. So the area of the circle is going to be pi times 8 squared divided by 2. And let's just pop that into a calculator. Well, that's 64 pi over 2, which is 32 pi. I'm just going to leave it as 32 pi, actually. I'm not going to round anything just yet. I'm going to only round my final answer. So the area of the semicircle is 32 pi. So we can now work out the area of the shaded region. Area of shaded region. Well, that's going to be the whole rectangle minus the shaded region. So it's going to be 304 minus 32 pi. Okay, so that is the area of the shaded region, but we're asked to calculate the percentage of the area of the rectangle that is shaded. So it's going to be this quantity out of this quantity. So this is the shaded region, this is the whole rectangle. So the percentage shaded is going to be 304 minus 32 pi out of the whole rectangle, which is 304. Now this is as a fraction. To convert it to a percentage, we just need to multiply that by 100. So I'm going to put all of that into the calculator. So 304 minus 32 pi divided by 304 times 100, and we get 66.93%. Let's look at the question. Give your answer correct to 1 decimal place, or that would be 66.9%. Question 28. ABCD is a trapezium. A square has the same perimeter as this trapezium. Work out the area of the square. Give your answer correct to 3 significant figures. So we're told that the square has the same perimeter as this trapezium. So we need to work out the perimeter of this trapezium first of all. And we're given 3 of the lengths. We just need to work out what this missing length is here. Now what we can do is I can see that this length is 5 centimeters. So that means this length here is also 5 centimeters. Now we can work out this length here. This sort of, if you think about this triangle, this is a right angle triangle. We can work out this length because we know the whole length is 9. This length here is 7, so this has to be the difference. So that has to be 2. And now we know these 2 lengths. We can calculate this length because this is the hypotenuse of a right angle triangle. So we can use Pythagoras. So we can say that CD, this length CD, well, it's going to be the square root of 5 squared plus 2 squared. So let's just pop that into the calculator. So the square root of 25 plus 4, well, that's the square root of 29. And again, I'm just going to leave it like this. I'm going to round when I get to the very end. So the length of CD is the square root of 29. So the perimeter, well, we just need to add up all the sides. So it's going to be 7 plus 5 plus 9 plus the square root of 29. So 7 plus 9 is 16. 16 plus 5 is 21. So it's going to be 21 plus the square root of 29. That is the perimeter of our trapezium. So the square, if we think about the length of a square, so let's just write this down. Side length of square. Well, we know it has the same perimeter, so we just need to divide this by 4. So it's going to be 21 plus the square root of 29 over 4. Because each length is the same. Each length is the same. So now we know the side length of the square, we can work out the area of the square. So area of square is all of this squared. So this is the side length, so it'll be this times this. So it'll be 21 plus the square root of 29 over 4, all of that squared. And now I'm going to put it into the calculator. So I always like to put it into the calculator right at the very end, just so I don't lose any accuracy. So if you just bear with me one moment while I type this in. And we get 43, I'm just going to write down a few decimal places, 511, and that would be in centimetres squared. Now it says give your answer correct to 3 significant figures. Well, that's the first one, that's the second one, so it would be 43.5. 43.5 centimetres squared. And that was the last question on this video. So hopefully you enjoyed this walkthrough. Like I said in the previous video, if you have any questions, or if there's any topics that you want me to go through, or if you've got any questions about the exams, anything like that, please post them in the comments and I'll get back to you as quickly as I can. So there's one more video in this series. So I'm going to do paper 3 next week, which is also a calculator paper. So thank you for watching, guys, and hopefully I will see you in the next video. Take care.